Well, good afternoon, everyone, and welcome to this next session of the 2021 Northwest Wisconsin Lakes Conference. My name is Mike Engelson. I'm the Executive Director of Wisconsin Lakes, and I'll be moderating the session along with my co-host Eric Olson of Extension Lakes. And we're very happy to be joined today by Captain Tim Tyre of Terra Vigilis Security Group and Professor Mike Mortensen of Carroll University. They're going to present on the North Lake Wave Propagation and Water Quality Study. This is I believe the third or the fourth time that I've seen them give this presentation, and I learn something new every time that I've seen it. They presented back in April at Water Week, but were part of co-presenters and only had like 25 minutes. So I thought it would be great to give them a little extended time. And I imagine that you all are going to have plenty of questions for them as well. So Captain Tyre, as I said, is CEO of Terra Vigilis Security Group, which specializes in critical infrastructure protection and environmental impact studies. And Professor Mortensen is a faculty member at Carroll University, who is also Chief Science Officer with Terra Vigilis. Both individuals have research backgrounds in applied aerospace commercial technologies. And a couple of housekeeping things before we get started. If you have questions, please type them in the chat. You've probably heard that all day. And I presume we'll have some time at the end for some open questions. But for now, I will turn things over to our speakers.
Well, again, thank you very much for inviting us to be with you. And we have a lot of information to cover, so I think we'll just sort of jump right into it. Mike and I are sitting alongside of each other, looking at the same PowerPoint slides that you all are looking at. So let's just begin with a little bit of background on North Lake, which is located in the northern portions of Waukesha County in the southeast portion of Wisconsin. This study that you're going to look at was a preliminary study. We are now into a phase 2 version of this same thing, which is looking at many of the variables we addressed in what we'll go through today with you in more depth. So it's entitled the North Lake Wave Propagation and Water Quality Study. It was a phased study, meaning it's 3 years in a row. We're now in our second year of water quality and wave propagation physics impacting this small southeast Wisconsin freshwater lake, North Lake. You're looking at a picture of North Lake from the air at about 400 or 500 feet above the surface. You are oriented looking to the northeast. This is a lake which is approximately 440 acres. The largest body of water that you're looking at with vessels way up at the north end is what we refer to as the Big Lake. The one to the left of this screenshot is the Little Lake. They're joined together with a reef that runs all along the left portion of this imagery. And you can move from one lake to the next through a small dredged channel, which is just below the letter N in North Lake. That's about 3.5 feet deep. It's only about 2 feet deep right now because of the drought down here, but that's how you move through. This is considered a drainage lake. It has 3 inlets and 1 outlet. I'll show a slide to you that'll make that a little bit easier to see, and then we'll come back to who's been involved in this. So up in the top right-hand corner of this slide where it says Site 5, you'll see an inlet from the Oconomowoc River. Over to the left, top left, you'll see, it's hard to make out, but there's also an inlet there called Mason Creek, which is a very small stream which produces a lot of nutrient inflow from farmland north of here. The bottom portion of the large lake near Site 7, to the left of the word site, there's also an inlet that comes in from Cornell Lake and Pine Lake. And off to the side of Site 4, you'll see a meandering outlet that moves itself down to the rest of the lakes in the watershed here. So the next lake down is Okauchee Lake. North Lake is unique for several reasons. In the bigger lake, we have several deep basins up to 75 feet deep. In the little lake, which is only 108 acres compared to 338 for the big lake, we have one deep bowl. But in particular, I draw your attention to the brown shelf that exists all around that lake. That goes out about 100 feet or so, where the water is about 3 to 4 feet deep, and then it drops off. And it goes down like the big lake to about 75 or 78 feet, something in that range. So what did we do here? We put together a very interesting team of folks with research backgrounds. I was trained in psychology and did a lot of research in that area, human factors, and then became a professional aviator. So I am on the faculty there as an adjunct in the aviation science department. Mike is my boss. He's the director of aviation science. Joe Pyatt is a professor of chemistry and environmental science. Julio Rivera and Katie McCarthy are both professors of applied business analytics. Some people say, why would business analytics people be involved in a study of this type? The answer is that water quality has an impact on the economics of property value. And it's one of those secondary effects that people don't think about right away. But certainly if you talk to real estate agents, they pay great attention to the quality of lakes and their waters when they're trying to sell and buy properties. Well, last summer we had 2 university interns, Alex Navin and Jenna Bales, and we collaborated in the study with the Southeastern Regional Planning Commissioner Sewer PAC, Tom Slavsky and Dale Buser, both of the Southeast Regional Office. And finally, one of the other Terra Vigilis members was out here with professional drone flying. So both Mike and I'm a regular aviator, flight instructor, but I'm a commercial drone pilot as well. Mike is a commercial drone pilot, and so is Chuck Howard. So we have commercial drone pilots doing some of the science data gathering in this study. So that's the team. It's a closely collaborative team. So what we did here dates back about 5 or 6 years. There were the introduction of wakeboard boats on this lake, which was controversial in the sense that some of the residents were concerned about the wave heights and observations about impact to shoreline and the size of the waves on other vessels. And so the lake residents, there's about 230 residents that live on North Lake, expressed their concerns in a survey to the management district for the lake. And the survey produced a groundswell for a study or a look at how the lake is used and all the different kind of watercraft that are used on the lake. And that triggered a set of safe boater guidelines, which were designed to get everyone to be a little bit more courteous, and in particular for the wave enhancing vessels to stay out towards the middle of the lake. We also had some guidelines, including recommendations for slow no wake times on weekends past 6 p.m. The effort, which I was involved with, I live on this lake, was to try and softly change the culture of the lake to protect the residents, the property values, and the use of the lake for everyone who uses it. In the course of the surveys that were done after that point, we did 2 additional surveys to all residents on the lake with very high return rates, better than 50%. The residents expressed interest in a water quality study. And so the North Lake Management District came to Terra Vigilis, which does environmental study, and said, can you help us? And we collaborated with Carroll University and then with Sewer PAC to put together a team to look at traditional measures of water quality, but to add the technologies that are available through drones, both aerial and subsurface drones. And so that was our unique piece in this collaborative effort, in addition to designing the study itself. So what you're looking at in this slide are some of the technologies, not all of them, but some of them that were used in this preliminary study. So top right-hand side, that's a Phantom 3 aerial quadcopter with photographic equipment connected to the bottom of it. The left-hand side of this slide shows one of our technologies that we developed, which is a subsurface rover with cameras and sensing equipment on it. And then you're looking at, in the middle on the orange table there, there is something we call Aqua, which is a patent pending device that we've developed that does all of the traditional measures for water quality, but it does it robotically and independently. So pH, dissolved oxygen, turbidity, temperature, and sonic sensing of wave heights can all be done by this device. So those technologies were in use for this preliminary study, in addition to traditional measures of water quality. So there, those of you familiar with these things recognize the Secchi discs. We also designed a pole for measuring wave heights in addition to 3D imagery. Turbidity tubes, we had Nest cameras out to count boats. We used a multi-sensor probe for DH and temperature. I'm sorry, DO and temperature and pH. And then we had a subsurface drone in addition to the one I showed you in the last slide, which did a lot of videography of bottom characteristics, and we'll show you images of that in just a little while. So this study took traditional measures of water quality and mirrored them with high technology drone capabilities. And that was part actually of the original preliminary study, was to see whether the drone technologies could enhance what you would traditionally get in a water quality study, and in particular, a study that looked at wave propagation physics. So we decided that the study would have 3, I believe, or maybe 4 domains. The first domain that we looked at was measurement of wave physics itself. So wave heights, frequencies, duration, and depth, including subsurface impact of the primary engine-powered vessels that are in use on North Lake. And that includes pontoon boats. About 65 to 70% of the powered vessels on the lake in use by survey are pontoon boats. And then personal watercraft, water ski boats, and finally wave-enhancing wakeboard boats. I would say specifically here, relative to wakeboard boats, we looked at 2 different kinds of wakeboard boats: traditional wakeboard boats that you can water ski behind or wakeboard behind, and wake surf boats, which are a distinct particular mode for a wakeboard boat, where they flood the stern, they bring the deck angle of the bow up about 12 to 15 degrees, and they go very slowly, which produces a very large wave. So we looked at both modes for wakeboard boats. We did aerial mapping to give us 3D aerial maps of the shoreline, so we could get some baseline data on shoreline status. And we also did 3D modeling of waves. So we did traditional wave height measurements with a stick and heights, and then we did 3D modeling as well. So this first slide, which is a little busy, I'm going to try and walk you through it, and maybe it's easier to get through the numbers if we first show you what the differences are between wavelength, wave height, and time. So if you look in the middle of this slide, wavelength is defined as the distance between the crests of the waves. Wave height is the distance from the bottom portion of the wave to its height, so from the trough to the crest. We took measurements of wave propagation about 45 to 50 feet from the shoreline, of waves that were being propagated about 200 feet away from the shoreline. And as this slide shows, we looked at wakeboard boats, pontoon boats, and jet skis. Now we'll walk back to the number data here. So left side, this is a wakeboard boat wave. The wavelengths varied between 12 up to better than 20 feet. So that is the distance between the crests. And we'll show you this with some imagery that makes it much easier to appreciate what that means. The wave heights were a combination of plus and negative numbers to get a total height. So if you take the second sequence of numbers, 17 feet dash 11 inches, so almost an 18-foot wavelength, that was at its highest 8 feet above a baseline and 2 inches below in the trough. So if you add the two together, you have a 10-inch wave. And again, we'll image this so you can see it. You can compare those waves, which are very different. And most folks in an audience who live on a lake or visit lakes, if you've been on a shoreline and you simply watch what these waves look like when they roll in, they're, to the naked eye, a very different phenomenon. These numbers simply codify what you see with your eyeballs. So big waves, a lot of wavelength and a lot of height, and some pause between. Pontoon boats, distances are less, the heights are less, and jet skis, much less in terms of wavelength and much less height. Now, numbers get busy. People sometimes get sleepy when they look at numbers. And so we will show you an enhancement of what we measured by running this little video. So if you look on the left side, those are waves generated from a speedboat. If you look on the bottom right-hand side, those are waves closer together, as we indicated, generated from a jet ski. If you look at the top right panel, you are seeing waves propagated from a wakeboard boat. The distances between the waves are longer. In other words, the wavelength is longer. They are higher. In some cases, if they get beyond 10 inch, they crest and fall on top of themselves, or what they call a white cap. So they're different waves. Whether you use numbers or visual imagery, clearly it is a different kind of wave. The physics involved is very different from the propagation of the waves. Okay, the other thing we did was to look at the waves as you would see them if you were standing on the shoreline. And this panel is going to show you what they look like from the air, underneath the surface, and if you were standing on the shoreline simply looking out. The first we're going to show you is an aggregate wave produced by a jet ski passing behind a pontoon boat. And they were in a little bit closer than these boats normally would be for purposes of just getting the data. But if you watch close top right, you'll see the wave beginning to roll in towards the shore. You'll notice just as it hits that little swim raft, now it's coming over the brownish area, which is the shallow crest all around the little lake. And if you look bottom right, you'll see what it does to the bottom, which is not much. So we're trying to give you almost a fisheye look at what the wave does under the surface, on the top, and along the shoreline. So that's a combination deliberately done that way. So we were trying to get a compounded wave effect from both a pontoon boat and a jet ski in a little closer than they would normally operate. They're supposed to be 200 feet away from the shoreline. Now we're going to look at the differences with wakeboard boats, waves propagated by wakeboard boats. So this is a wakeboard boat. These are wakeboard boat images. So that's a wakeboard boat in surf mode. So the stern is flooded and it's down with the deck angle up high, and it's moving very slowly. If you watch close, you'll see the waves rolling in. And if you go to the swim raft up in the top right, you'll see the wave approaching the swim raft. Now that surf boat was out about 200 plus yards from the shoreline. So this is a big wave coming in on the surface. What ordinarily people don't pay attention to is what happens under the surface. And so I draw your attention as it moves through and gets to this shallow area, what happens on the bottom. That's about an 8-pound rover that we had sitting on the bottom in about 6 feet of water. And you'll see what happens to the rover. It gets knocked around. Now, if you look top left, you'll see the wave coming in. And of interest, it's scrubbing the bottom, so it's stirring up sediment. Well, this is not something we anticipated, it's just observed with our studies, so it was of great concern, particularly to the sewer pack people. So again, very different waves from 3 different kinds of vessels on a recreational lake in southeast Wisconsin. Now, Mike is going to talk a little bit about the technology that we use to make sure that our data is reliable, meaning we fly the same routes every time. And I'll turn it over to Professor Mortensen.
Yeah, we use really several different drones, but the workhorse is for what you're seeing here is the Phantom 3. And we also use a few different software packages, Drone Deploy and Pix4D. But we'll take our drones out and set up a route for that drone. This picture just shows a quick example of a predetermined route that will have a drone go up and image over a certain period of time. And then we'll take that imagery and bring that into either one of those applications. They'll stitch all these images together. And then from there, we can, just from using cameras pointing down in the nadir position with the stitching and the RGB values, we can take that information and actually turn that into 3D models. We can also determine volumetrics, with some of this imagery as well. So you're just looking at kind of on the small lake of North Lake, just a very small area that we've mapped, but currently we're mapping the entire small lake this week with our drones. So yeah, we have several drones that do a lot of different things. And right now we're doing this mapping technique using a few different software applications.
Let me just add as well, one of the really positives of this particular technology is that from a research point of view, it handles the issue of reliability and validity. This is a drone flown at a precise height every time in the same pattern every time. And so confusion about camera angle or height or differences that would confound the data are handled because it's exactly the same route every time.
The other thing that we do here is we'll have surveyors come out and give us what are called ground control points. So we have a certain level of accuracy with these models. So every year that we would map, we can then take the model and do a study along the shoreline. And this is crazy image actually, is a polygonal model, a 3D model that was converted from imagery. It's a general description of what we would see after doing the mapping. There'll be a lot more detail to this, but this is actually a shot, aerial shot looking toward the shoreline, and that's actually a dot coming out from the point there. It's the accuracy is down to inches, so we'll be able to go in and compare that over time just at this specific point and see if there's any erosion occurring at this specific spot. Another thing that we're looking at is using different types of cameras for our study. One of those is a multispectral imaging camera that takes different wavelengths that we can run through certain applications that can give us some information. What multispectral would be typically used for is for farming and doing the health of vegetation. But we're also looking at shoreline and even some imagery as far as sedimentation plumes at or near the surface of the shoreline. So we're working with that imaging today. There's also hyperspectral imaging out there as well that we'll be looking at down the road here. But we didn't get too far with this part of it. We're still studying the imagery, but this kind of shows the different images that are shot with that camera.
Again, I would remind the audience that all of these data sources are compared with traditional data sources. So we're getting a closer look at the same variable, but with the efficiency of the technology of the drones. I said there were several domains. So the first domain had to do with wave propagation and the physics of the waves and what were the differences between powered vessel waves, both surface and subsurface. The next domain was to look at the impact of that on the lake itself in terms of the water quality. What is the chemistry of the lake as a result of all this activity? So we did water quality measurements of dissolved oxygen, pH, Secchi depths, water temperature. We did lab analysis over Carroll University using their ion chromatography facility. So we got concentrations of chloride, nitrates, and sulfates. The other common anions were not particularly abundant in North Lake, which is a good thing. We did get organic compound contents of sedimentation samples from the lake as well, and we'll show you some data that reflects that information in a bit. So domain 2 concerned itself with the chemistry of the lake itself now. So one of the nice things about the imagery here was, if you remember the slide I showed you, and I'm just going to kind of hover over this, these again are the 7 sites where we took measurements. And in this particular slide, you see temperature readings over time from June through August. And on any given day, we can get a dissolved oxygen. Let's pick, I'll click on this one.
That's just video.
Oh,
It's
I'm
not
sorry.
interactive.
I'm sorry. Okay. Let me go back. We would have to hook up an add on to this, and I'm not going to do it now. But if I were to click on any one of these histogram bars, I would get a specific date. I'd get a date that would include a barometric pressure, temperature, surface winds, in addition to those temperatures. So we can look at all the potential confounding variables that are involved with changes to lake chemistry for dissolved oxygen. The preliminary study looked at surface dissolved oxygen in 1 to 3 feet. Phase 2, which is what we're in now, is looking at dissolved oxygen levels below the thermocline, which it becomes important to know about because of its impact on biologics, on fish life. So we'll have more to say about that when we finish our work this summer. So in these slides, you're looking at the things we looked at in terms of water quality, which was dissolved oxygen over that time period, June through August. Secchi depths for water quality, and again, you see it go down as it heats up, which is typical. pH and temperatures also trends down through the summer months and get into August when it's persistently hot.
So that we're with all this data, this is actually interactive maps that we can view through a web browser through ArcGIS. So we are using storytelling with this data through that application. So all this data is interactive.
Domain 3, we have the capacity technologically to get under the surface and take video of the quality of the bottom and the plant life. So we did a survey of plant life in North Lake so we could be precise in passing information to both Sewer Pack, the North Lake Management District, and the university on the kinds of plants that are active in the lake and what particular species they were. And but before I show you all the plants, which are interesting in and of themselves, we want to talk a little bit about this. This imagery was taken at the end of the summer at about 15 feet all along that Wildwood Point reef that I showed you in the first picture where the study began. So this is what happened on a reef that at the beginning of the summer had lots of plant life and fish. By the end of the summer, it had this covering of stirred up sediment that had pretty well smothered out the plant life, and we don't see any fish. And we ran this particular survey several times at those depths up and down that point, and that point is about 400 yards long. So it's a rather dramatic piece of imagery on what's happening with re-deposition of sediments. We'll have some aerial views that will show you where they seem to be coming from, where the sediment is coming from on the lake. But it's certainly it's a disturbing image, I guess. Certainly for the marine biology folks who looked at this, who were concerned about the impacts of the redeposition of the sediments. Okay, as I indicated, we also took underwater photography and sampling of plant life all through the lake. And at sites 5, 6, and 7 on the big lake, we took these samples back to the lab. They were dried and categorized, and we now have a pretty good idea about the plant life culture in North Lake. Again, useful information passed on to the North Lake Management District, which is the governing body that sees to protection of the lake. So sago pondweed was found. For you in the audience that are familiar with these things, these will be easy to understand. It's hard for an aviator to understand. There's a Eurasian milfoil, invasive species. Vallisneria or eelgrass, native to Wisconsin. I said there was a fourth domain. The fourth domain came up, as sometimes happens in science, by serendipity, and that was when we had aerial drones mapping the lake. We discovered the development of plumes that were being generated by the wash from some of the vessels that were operating, particularly the wake surf mode vessels. They were propagating wave effects that produced plumes, and those plumes were spreading, and we'll show you some imagery that makes that clear. So it isn't just what I'm saying. So if you look on the left-hand side of this slide, you'll see plumes that are moving towards the reef. And here you'll see it rather dramatically. If you draw your eye to the midline and then move to the right, the sediment that's stirred up moves over to the shoreline and then runs up the edge of the shoreline and pops over that reef. And that is the reef that we had the underwater footage of that was covered with all of that sediment. So these plumes, are a concern. We will leave it to the subject matter experts in marine biology and hydrology and limnology who can tell us, what it means. But from someone who just looks at it, it doesn't look like a good thing to have happen. And it may account for why water clarity changes and why we may have some impacts on fish habitat and fish life in this lake. So we're going to know more about that at the end of this summer in our phase 2 work. This is an aerial view of the big lake at North Lake. At the south end, there's a great big reef there as well, and boats congregate on that reef for the summer for recreational purposes. And this gives you a kind of an aerial sense of the size of the lake. Again, the plume development, particularly dry side where it jumps across the point and redeposits on the other side. And that's happening all along that reef between the two lakes. And we have lots and lots of imagery of this and footage of this. Again, the sewer pack folks were particularly concerned with this event. So we're looking at this specifically this summer about where it comes from, where it goes to, and its impacts. So in our preliminary study, which was done last summer, we had these highlights summarized. The preliminary data showed significant or clear differences between wave heights, frequencies, and duration of waves for both surface and subsurface depth and wave energy produced by different kinds of powered vessels, pontoon boats, personal watercraft, and wakeboard boats. Number 2, the preliminary data showed development of sedimentation plumes from wave enhancing vessels, which appear to have impact on the shoreline. Again, this phase 2 study this summer, we're going to have much more data on what that actually means and what its implications are. Number 3, the preliminary data showed sedimentation elements which have potential for impacting plant growth. So as you stir up the bottom with waves that have both surface and subsurface energy, you're pulling up nutrients that have an impact on plant life. Again, that's something we're looking at in great detail this summer. So we're looking at phosphorus, non-soluble phosphorus. Number 4, the preliminary data showed variability in water quality and dissolved oxygen levels in selected portions of the lake. But in the preliminary work, we didn't do deep dissolved oxygen levels, and we're doing that this summer, below the thermocline. Number 5, preliminary data allowed identification of selected chemical compounds in the water of North Lake, which merit additional study. We're doing that this summer as well. And finally, we were able to identify a range of plant species which have both positive and negative impacts on the lake and merits additional studies. So we'll look at some of the plant dynamics as well, with direct implications for what the management district decides to do with its weed cutter and chemical treatment protocols, et cetera. And that is essentially a summary of our efforts from the summer of 2020. We are now in phase 2, which is partially funded by the Wisconsin Department of Natural Resources, to look more specifically at the depth of downwash on wakeboard boats and compare that with pontoon boats and other boats. We want to see if we can compare our data with the data coming from other university studies which have looked at downwash plumes from wakeboard boats in wake surf mode, which is estimating significant downwash effect beyond 12 to 15 feet, which would certainly have implications for a lake that's got a shallow perimeter like the Little Lake on North Lake or other very shallow lakes. And in addition, we're looking at water chemistry this summer. And I guess we can finish here and see if there's questions for us. I don't know where we are on time, but we're happy to take questions.
Yeah, we're doing really well. We've got about 20 minutes, I think.
Oh, perfect. Okay, great.
So if you have questions, feel free to put them into the chat and I can pass them along. We did have one question regarding funding. You mentioned the surface water grant partially funding the phase 2 of the study. If you're able to disclose, how else did you make all this happen?
Well, we donated services. Last summer, we donated probably 70% of what we were doing out here was donated. This summer, the North Lake Management District, in addition to the DNR surface water grants, they were funded on 3 of them, have supplemented that so that our time and technology and the university interns and the lab fees, they're all being underwritten by a combination of efforts by the Wisconsin DNR, thank you again, and the North Lake Management District, thank you again.
Great. Jesse's wondering if you know about how many wake boats are on North Lake?
The unofficial count is 24. Of interest on those 2 lakes, the Little Lake and the Big Lake, 19 of them live on the Little Lake. And there are other folks moving on the lake and bringing those vessels with them. I would say that having been a resident here for a long time, people are generally very reasonable. And when they have access to accurate information like this, they go, oh my goodness, I had no idea. So I will certainly cooperate with a recommendation to stay out in the middle of the lake and as much as possible, try to get out to the Big Lake where there's more room to dissipate the energy from the waves that are being produced. But there's a fair amount of wakeboard boats on this small lake.
Would you consider the lake to be pretty heavily trafficked in general, just wake boats and other, I mean, the many lakes in southeastern Wisconsin, especially, I've heard, at least anecdotally, or the feeling is that they're close to their carrying capacity, that they're the number of boats on the water at any one time is getting high. Would you characterize North Lake that way?
I don't know. We're gathering data on wake, on boat counts. So we'll have a better way to answer the question with a real number. So I don't really know with certainty. Anecdotally, being a resident on the lake, I don't see as much boat traffic this early spring and early summer as we did last summer. And, who knows what that means? Maybe it's a COVID-related phenomenon, but I don't know. In addition, I would think it's important to say that I don't know of a number against lake acreage that is used or is a standard in the industry about how many boats belong on what size lake. I don't know of such a number. I've heard that phrase, but
There are some studies that have been done. There was actually one done in, I think, 2003 on Lake Ripley near Cambridge that came up with, at least for Lake Ripley, a general range of 10 to 30 acres per boat, depending on the prevalence of the activity. So if there's a lot of like high speed, intense use traffic, then you obviously need more acres per boat. If it's just relatively stationary fishing boats, you can put more on a water body without having a problem. And that was based on, I believe, mostly studies of personal reactions to when, national industry studies of personal reactions to when the number of boats became too high. It wasn't necessarily tied to environmental impact, or I don't even believe safety. But I actually just did a presentation on this just last week. So this carrying capacity and all these kind of issues are something that Wisconsin Lakes is working on quite a lot. Eric says we accept weight limits on roads to ensure that massive vehicles with heavy loads do not wreck the pavement. What would you think about adopting load limits for lakes based on the science of that the lake itself can accommodate? Kind of what we're just talking about, I think.
I'm interested in what Mike has to say about this. I'll give you my sense of it. I'm basically trained as a scientist. And so I would like to follow the science, and whatever the science is then interpreted as by subject matter experts in marine biology and hydrology, I would hope that that kind of information informs decision makers who establish public policy for the common good. That's how I would answer that question. And Mike may have some things to say as well.
I agree with that. I've come from more of a visual area expertise in visualization. So as we study this more, I'm sure I'll have a better feel to answer that question, but I would concur with Tim on that.
I'm curious too, I haven't come across this in any of the other studies that I've looked at, but have you thought about or looked at how, when you have multiple of these types of watercraft, so let's keep it simple and say that you've got 3 or 4 wake boats operating on the water at the same time, of any effect of either multiplication of force of those waves as they run into each other, or cancellation?
Yeah, that's an excellent question. We've certainly thought about it. And that, you might remember, I specifically said we tried to aggregate waves between a personal watercraft and a pontoon boat, and we were in close to the shore. We did that deliberately so we could see if that was producing a compounding effect. And it didn't have as much impact as the wakeboard boats that we measured, as we showed you in those slides. We have not specifically studied the effect of aggregating many different wakeboard boats operating at the same time, but we're following the science from other studies being done. And certainly if you have boats that are capable of producing downwash plumes that get pretty deep, and you have several of them operating simultaneously, it's a scrubbing phenomenon that would be of concern. But we have not specifically studied it, so I don't have an opinion.
Yeah, and certainly the visuals that you've presented seem to bear that out. that scrubbing phenomenon certainly is there. Other questions that people have, feel free to put them in the chat. We still have some time left. Otherwise, we're going to get a nice long break before the next session.
Mike, this is Eric. I guess I would just ask, this is an investment in sort of one lake with a very specific type of shape to it. Its subsurface shape will probably influence a lot of what's happening here, plus the vegetation that exists shapes it. What are really the prospects for doing additional lakes in this similar way? Like, how much time and effort would that take to start extrapolating out? Or do we just need the bathymetry of the lake and maybe some sense of what the sediment is?
If you're asking that question to us or an opinion about that topic, we've been contacted by many lakes all over the country, actually. But happily, there's a couple of lakes that are near us, one in particular that is similar in characteristic. So it's a perfect opportunity to compare, kind of like in a laboratory, pill A and pill B given to a similar subject. So this is also a lake which is about 100 acres or so, like the Little Lake. The primary focus of our study this summer is on the Little Lake, on North Lake, by design of the funded grants. And so we're going to be in a better position to answer questions like that, I think, at the end of the summer when we have more data. And the more data we get, I think the more compelling the information really is. I mean, anybody that just simply looks at these things, it is clearly a different, it's a different animal that's producing these large waves.
And I'd throw out too, there are a number of different studies that either have been conducted or are being conducted now around the country on different lakes with similar characteristics as well. I know of one that was done on, I think it's Payette Lake in Idaho.
Correct.
Just saw a study last week. I'm not sure how new it is, but that was done on a couple lakes in northeastern Georgia.
The one up at the University of Laval in Montreal, a very carefully designed study, good engineering and research design in that study, which does show downwash plumes with the newer technology wake surf modes of 15 to 20 feet. So, the data is beginning to accumulate. We're waiting to look at the data coming from the University of Minnesota, the St. Francis Lab studies. They're coming out here real soon. So there's more and more carefully designed studies that don't get ahead of the science. They stay with the science and they're careful to limit the generalizability of the findings. There's a series of those things coming out, which are coordinating and observing similar phenomena, I guess I would say.
Couple other questions and comments in the chat. John, and I think I probably am interpreting this correctly, that there's a level of incredulousness to the way he says this. Did I hear you say that there are 19 wake boats berthed on the 100-acre Little Lake and 6 on the 300-acre Big Lake? I know that's the way I reacted.
Yeah, I think that's correct.
And
yeah.
do the ones on the small lake mostly stay there, or is there a lot of movement between the two?
Well, we're encouraging movement to the larger lake,
Sure.
Number one. Number two, because we're in a drought, the lake levels are down. And so the only way to move them from the little lake to the larger lake is through a dredged channel, which is shallow. So it's burdensome on the owners of those vessels to get them to the bigger lake. I mean, it's possible that's how they get them to the little lake to begin with, but so there's an effort afoot. I think there's permitting that's been requested from the DNR to open that channel up to allow these boats to get into the bigger lake to dissipate some of that energy.
Sure, where it might be have at least less impact, right?
Yes.
Caroline asked, does the drainage of the Economwalk add to the sediment load on the Little Lake?
It does, although that's not part of what we've studied. This is a lake which about 15 or 18 years ago had a dumping from the Oconomowoc River from a dam upstream that settled out in the north end of the big lake. And as long as nothing disturbs it, I guess it's not so much an issue, but there is a heavy load. Estimates are anywhere from 4 to 5 feet deep of muck that came in when that dam was pulled out, that just settled out at the north end of the big lake. So that's a concern as well.
Mhm.
One of the things we're looking at this summer, by the way, includes total suspended solids and phosphorus to see if we can measure any movement of that kind of material down through the Oconomowoc River into the other lakes in that chain, including Okauchee and Oconomowoc and all the rest. So what happens here is impacting a whole sequence of other lakes as well.
Sure. Other questions for our speakers? Oh, this is a good one. Additional ways that a drone-based water quality measurement system could be deployed beyond studying wake boats. Do you have other ideas of other things that your technology that you've put together for this could be used?
Well, we've developed this patented system called Aqua, and I'll have Mike talk to you a little bit about that because he's our James Bond Q that goes into his lab and comes up with these marvelous pieces of technology. So he can tell you all about Aqua.
Yeah, we've been working on this for a while. It's really interesting. It's a way to deliver sensors to parts of the lake with a drone, and then having that fully automated so that it can, capture data that would be hard to get at, that you just couldn't take a boat out to. So, we've created this piece of equipment with a lot of thought into carrying capacity for these drones. We were looking for something as far as a smaller drone that could carry the weight and not something really big, so that you could take this drone pretty much anywhere. So yeah, there's a drone. It's really interesting because a drone can carry up to about 4 pounds. And if you look at all the different sensors that are out there today that are off the shelf, from gas sensors to moisture sensors, you can design these and actually create, prototypes or 3D models that you can put on these drones and send them off to, maybe capture and analyze, gases in the air. So this is kind of one area that we're actually focusing over at Carroll University with our drone miner, which is really the first in Wisconsin. So yeah, there's a lot of applications that we can add to drones as a delivery system with sensors, and we're looking at a lot of different ways to do that. Just another interesting thing that we're doing is the term bathymetric, was mentioned. We're doing 3D models of the lake as well, and we're able to we're going to be modeling and simulating the downward wash from these boats, and so we'll be able to kind of move that around the lake and kind of figure out, where these are touching the shoreline, or the depth of the shoreline there. But yeah, there's so many applications with drones that we're looking at, and Aqua is one of those that we actually built and are testing out this summer. It's really quite interesting. This thing goes in the water and it, goes at different depths and captures the data, and the drone comes back and picks it up.
That's really that's just really cool, and I think it's really great seeing the partnership between the university and the Lake District and the company to do all this kind of work. I mean, this is exactly the kind of stuff that we talk about in the Lakes and Rivers Partnership that we need to foster. And I think even if you take out the subject matter, just seeing the whole process of what you're doing is really, really great and really interesting. John asks about any information on the demographics of the two lakes, you know, age of residences, the length of time that they've been there. And I'm guessing that maybe he's getting at the idea that that might be an important question in terms of determining how education efforts, you know, once you get this science going, the kind of education efforts that knowing who it is that you're talking to is important. So that that might be the case.
That's an excellent point. And I designed the 2 surveys that were used by the North Lake Management District to look at the impact of the safe boater guidelines that were promulgated through the North Lake Management District. And those, again, as I mentioned, were designed to kind of impact the culture of the lake and have people feel responsible for protecting the ecosystem, et cetera. And we didn't ask any questions in the surveys so that we weren't intruding upon or making it likely somebody would say, well, they're asking too many questions, I'm not going to fill this thing out. But I would say that the socioeconomic levels on this particular lake, this is anecdotal, but I've been out here almost 40 years. It's not an inexpensive date to buy a home on this lake. And the homes on the lake are in the $1 million range, and they populate around both the large and small lakes. So one could just extrapolate, I suppose. These are fairly sophisticated people with a lot of money invested in a piece of property. And our experience so far, I would say, this is my personal opinion, is that people are quite reasonable, actually, when they get factual information to make a decision upon. So if you tell people, look, this is the impact it's having, we've measured it in 6 different ways. Would you consider operating more towards the middle of the lake, or would you consider operating on the other lake, or would you consider having a slow no wake period of time on a weekend so that other people can enjoy the lake for in different ways? We've had really, I would say, pretty good response to that. There are some exceptions which often stick out and become the focus of a lot of energy and time, but I think the vast majority of people on the lake are pretty reasonable about protecting the lake and getting along with their neighbors, et cetera. It's an excellent question, though.
Yeah, and I think that's one of the reasons why I think it's so important that we get the kind of science that you're doing, and the way that you're doing it with the videos. It really lends itself to storytelling. I think you even mentioned that at one point, which is so important, that it's not just that we're not just throwing out science, that we've got the stories to tell, that people understand what it is we're trying to get done, so it doesn't just become you know, we're intent on stopping people from doing a particular sort of thing.
Yes, which is absolutely not our interest, period. It is not our interest. We're trying to gather the data and let the experts have an opinion and let that inform public policy.
Great. Well, I think that's about, we're about run up to our time. So I want to thank both of you. Everyone, if you want to give them a reaction, I think you probably know how to do that by now with the hand claps and whatnot. Like I said, learn something every time. Every time I hear these presentations. I'm looking forward to hearing what the results of phase 2 when you're ready to talk about those next year. So. Again, thanks everybody for attending this session. We've got one more left for the conference. So that will start at 2:30, 15 minutes or so from now. So again, thanks, and we'll talk to you soon.